Afternoon, everybody. I'm Marco Motta. I'm a science journalist and science communicator, editor and host of Radio Trescenza, the daily science radio show of the Italian Public Radio. I'm really pleased and happy to be here with you all this afternoon for this second meeting with the authors and the finalists of the Cosmos Prize for Science Communications for Students, organized, I do remember that, together with the Planetario Pythagoras of Reggio Calabria and the city of Reggio Calabria, with Ministero dell'Istruzione, Ministero degli Esteri. I want to say hello to all the students and viewers on YouTube on behalf of Gianfranco Bertone, the president of the scientific committee. Let me please, before introducing the two speakers of this afternoon, let me remind you the 5 finalist books of this 2023 edition of the Cosmos Prize. Jim Al-Khalili, Le gioie della scienza, Bollati Boringhieri. Roberto Battiston, L'alfabeto della natura, pubblicato da Rizzoli. Paola Cadelli, Rosalind Franklin, Ho fotografato il DNA, pubblicato da Morellini. Melanie Mitchell, L'intelligenza artificiale, una guida per esseri umani pensanti e inaudi, with whom we discussed recently here, and then finally Avi Loeb, Non siamo soli, pubblicato da Mondadori. I want to say hello to all the students who are just viewing us on YouTube. I don't have the time to mention all the institutes connected right now, but I just want to mention at least some cities also abroad. I remember that, from Barcelona, from Zurich, from other many cities in Italy, like Roma, Ischia, Vibo Valentia, Polistena, Bova Marina, Moncalieri, Potenza, Reggio Calabria, of course, and then Locri, Arzano, Altamura, Ortona, Sassari, Catanzaro, and again from abroad, from Madrid and Casablanca. You are all welcome to our meeting today, our intense dialogue that we are going to have this afternoon, because this afternoon we are going to address one of the most fundamental questions ever. Are we alone in the universe? That's a philosophical and scientific question, and you will discover, maybe if you are reading the book written by Avi Loeb, that in his personal career too, philosophy and science truly intersected, met each other. Of course, it's a question that triggers a lot of other interesting questions. How do we look for life in the universe? Could we be able to detect signs of other forms of intelligent life? And whenever and if it will happen, are we ready to accept? Are we prepared to accept the discovery and to meet eventually other forms of life? So it's time for me to introduce to you all the two speakers of this afternoon. First of all, Avi Loeb, good afternoon, and thank you for being with us.
Thanks for having me. It's a great pleasure, and I recognize some of the towns you mentioned in Italy. I really enjoyed going there during my honeymoon about 2 decades ago.
Oh, wow. Nice. So, Avi Loeb is an astrophysicist and a theoretical physicist. Is the Frank Baird Junior Professor of Science at Harvard University. He has been the longest serving chair of Harvard's Department of Astronomy for 10 years, and founding director of Harvard's Black Hole Initiative and many other initiatives in this sector. Of course, is talking about his book, Are We Alone? Siamo Soli, which was translated by Mondadori. And then Amedeo Balbi, good afternoon.
Good afternoon.
Physicist and cosmologist at the University of Roma Tor Vergata. He has written a bunch of interesting books in Italian. The latest one is Su un altro pianeta, c'è futuro per l'umanità al di fuori della Terra. So on another planet? Is there future for humanity outside planet Earth? But I want to remind you all also another book that he has written some years ago. Dove sono tutti quanti? Where is everybody? Actually, which refers also to a famous problem of Enrico Fermi, one of the most celebrated and important scientists in Italian history. So it's time for me to shut up and let the floor to Amedeo and Avi. So enjoy.
Great. Okay. So first of all, let me say hello to Avi, and let me say it is really a great pleasure to be here and to discuss this book. This book is a book that discusses a very controversial hypothesis, which is that an interstellar artificial probe passed through the solar system in 2017. And it is definitely a very stimulating and thought-provoking book, even provocative book to some extent. And so I think and hope that this is going to be an interesting conversation, because there are many things I disagree with, including the main thesis of the book, but there are also things I agree with. And one of the things I agree with you is that searching for life in the universe is very important. Perhaps is the most important open question in all of science. And so we should take this question very seriously. So I think it is an interesting scientific question to answer. So the first thing I want to ask is, you have an impressive record of research in all fields of theoretical astrophysics. What brought you to this topic, to the search of life beyond Earth, and why now? Is there something special in this historical period?
Yeah, so in fact, throughout my career, I worked on the first stars in the universe before anyone was interested in them. Nowadays, of course, with the Webb telescope data, a lot of people are interested in the first stars, first galaxies. I don't, attempt to get likes on social media. That's not my motivation. I want to promote our scientific knowledge. And that was true 30 years ago when I started working on the first stars. So that's an example of a frontier that was not popular. In fact, I had the PhD students. One of them is now the chair of the astronomy department, my successor, Daniel Eisenstein. And, at the time when I was studying this, a lot of people ridiculed this subject of the first stars. The same was true about black holes. I worked on imaging black holes 2 decades ago, and now it's a very popular frontier. Back then, not many people worked on that. And so what brought me to this subject is evidence. I'm a scientist. I was never fascinated by science fiction. I enjoy doing science, and I enjoy reading fiction. But very often in science fiction, the script violates the laws of physics. I have a problem with that. And as a result, I was really intrigued by evidence. And only over the past decade, we were able to detect the first objects from outside the solar system. It started with Oumuamua, that my book talks about, back in 2017. And then a couple of years later, with my student, we discovered the first 2 interstellar meteors. These are objects that collided with Earth, roughly the size of a meter. And we could see the fireball from them. And actually, this summer, we're going to look for the relics of one of these meteors, the first one from 2014, because it was tougher than all other space rocks ever cataloged by NASA. Again, evidence. It was able to maintain its integrity down to the lower atmosphere of the Earth and broke up, indicating that its material strength is tougher than iron meteorite by almost a factor of 4. And so I'm intrigued by that. I want to find out whether the first interstellar meteor was a rock of a type that we've never seen in the solar system, or maybe a spacecraft. Now, you can argue with me and say, well, I believe Oumuamua was a rock of a type that we've never seen before. And in fact, in Nature magazine, just a month ago, there was an argument of that sort, and I can explain why they made a mistake in the energy balance equation by a factor of 1 million. 1 million. We wrote a paper about that. And nevertheless, science journalists would keep describing this as a solution to Oumuamua when I told them there was a mistake. and they said, we don't want to confuse our readers. So you can, describe whatever narrative you want to argue that what we are seeing in the sky are rocks, even though they look different than all the rocks we had seen in the solar system before. And only over the past decade, we started seeing objects from outside the solar system. The first 3 of them looked extremely unfamiliar, very different. I can go into details. So I'm driven by evidence, nothing else. And sometimes I feel like the kid in Hans Christian Andersen's tale that said, the emperor has no clothes. And here the emperor, for example, is Oumuamua, where the mainstream view is, it's a comet. It's a comet of a type we've never seen before. And you cannot see the cometary tail because it's transparent. This is no different than the crowd saying, the emperor has beautiful clothes, you just can't see them. And the kid saying, I don't see any clothes. Oops, we cannot.
Sorry. I was talking, but my microphone was off. Yeah, getting to Oumuamua, which is arguably is the main topic of your book. There's no doubt in the scientific community that Oumuamua is as an interstellar origin, is coming from was coming from outside the solar system, and now it's gone, but it was coming from outside the solar system. So this is something that the scientific community as a whole has no problem with. On the other hand, as you reminded, the astrophysical scientific community as a whole thinks that this is a natural object. This is the explanation that
of a type that we've never seen before. You have to say that.
Yeah, precisely. That was my question. Exactly.
Just to explain, when you say
that is my question. So can you please explain why you are so convinced that these cannot be explained simply by a natural object and a natural phenomenon? And what is the anomalous evidence that you use to reach this conclusion? Can you explain that?
Right. So first, let me say the evidence for what I'm arguing is that the solution suggested by the mainstream are of something we've never seen before. They're not saying it's a rock similar to the rocks we had seen, and we had seen thousands of them in the solar system. What they're saying is, just like a cave dweller finding a cell phone, the cave dweller would say, oh, the cell phone is shiny, it's a rock of a type that I've never seen before, and throw it away. And then you ask yourself, oh, that's what the mainstream is saying, it's a rock, so it's a rock. No, it's a rock of a type that we've never seen before. Now, what are the suggestions that the mainstream are making? This object exhibited an excess push away from the sun. There is no doubt about it. There was a paper actually just a few weeks ago showing that again. There was a Nature paper back in 2019 showing that there was an excess push of the object away from the sun by some mysterious force. Why is it mysterious? Because we didn't see anything evaporating from this object. The Spitzer Space Telescope looked very deeply and put tight constraints on any dust or carbon-based molecules around this object. Therefore, it's not a comet. We didn't see a coma. We didn't see a cometary tail. The Spitzer Space Telescope didn't detect any traces whatsoever at orders of magnitude below what you would expect from a comet if this push was driven by cometary evaporation. You needed 10%, about a tenth of the object mass, to get evaporated in order to get this push. It's not a little bit of mass, it's 10%. And Spitzer Space Telescope put orders of magnitude, tighter limits on how much can evaporate from this. So now what does the mainstream say? Oh, they say, well, maybe it's a dust bunny, a collection of dust particles that is very loosely bound and pushed by reflecting sunlight. And the problem with that is such an object would get heated to hundreds of degrees when it comes close to the sun. You need it to be 100 times less dense than air, 100 times less dense than air in order to be pushed at the level that we saw, and it would not maintain its integrity. Just think about 100 times less dense than air on average, a cloud of dust. Okay, so then the mainstream said, oh, no. it's natural, but it's something else. It's natural, but it's a hydrogen iceberg, meaning made of hydrogen, not born in a solar-like system, in a planetary system, but born in a molecular cloud. So we wrote a paper showing that it wouldn't survive the journey. Over 1 million years, it will get evaporated by absorbing starlight. And the authors of that paper suggesting that it's a hydrogen iceberg agreed with that. They said, oh, sorry, yes, it doesn't really work. So then another group came forward and said, oh, we know what it is. It's a nitrogen iceberg made of nitrogen. Again, we've never seen a chunk of frozen nitrogen in the solar system. But they said, well, maybe if there is a planet like Pluto and it gets broken up by collisions, one of these fragments could be Oumuamua. And we wrote a paper showing that there is not enough solid nitrogen in the Milky Way galaxy to account for a population of objects like Oumuamua, which was the size of a football field. You need a large population so that one of them would come over the period of time that we searched for interstellar objects. Okay, so then the mass budget is not working. So then most recently, there was another suggestion. Oh, no, it's natural, but we know what it is. Now we know it's actually made of hydrogen. Hydrogen that was made out of water. So it started as a water iceberg, and then a third of the water molecules were broken by cosmic rays so that you get an outer layer made of hydrogen. And then this evaporation, the hydrogen is transparent. We can't see it. Therefore, it is a comet of water, very common comet of water. Now, what we said is, if you just calculate the energy balance of sunlight hitting the surface of this object and radiation coming from the surface, that's what this paper in Nature did. You have to account for the energy that needs to be invested in dislodging the hydrogen molecules from the lattice. And it turns out to be a term that is 1 million times bigger than the other terms that the authors included. And so if you include that, you get a surface temperature. The evaporative cooling reduces the surface temperature by a factor of 9, making this model untenable. It's impossible to account for the observed propulsion of Oumuamua. So again, this doesn't work. So I'm saying, okay, you can insist that it's natural, but you have to come up with a scenario that works. And moreover, all of these ideas are of something that we've never seen before. So I say, if all of the explanations that we can come up with as a natural object, other than saying it's a natural object, which was the initial reaction of the mainstream, if all of them involve something that we've never seen before and all of them have problems, we should allow the artificial possibility on the table. We should just allow it and look for more evidence. But you see what the mainstream is doing is saying, oh, no, forget about it. It's natural. We don't need more evidence. Let's move on. Let's assume that it's natural and move on. And I say that's the worst, because if you're not seeking evidence, you will never realize that there is something new that the universe is telling you. That was exactly the situation with Galileo Galilei. In Pisa, when he said, look through my telescope, you will see moons moving around Jupiter. Therefore, not everything is moving around the Earth. And the Earth may be moving around the sun. Okay, that's all. Very simple argument. But the clergy had an agenda. They didn't want to listen to him. And therefore, they refused to look through the telescope. Now, when you say it's natural and you refuse to look through the telescope, you're doing exactly the same thing. And I'm saying it's 4 centuries of history of science. And yet the mainstream insists of removing a possibility off the table, while all other explanations appear to be complicated, complex. It's not as if the situation is trivial. You know, if someone would have found a solution that is trivial and explains everything, I would say, okay, well, that sounds great. Now, in addition to the push of Oumuamua, there were other anomalies. It had a very extreme shape. It most likely flat. That was not my paper. There was a paper in Monthly Notices by Sergei Maschenko, showing this object was most likely flat and with an axis ratio of at least 10, you know, the long axis versus the short axis. So again, the most we had seen before in terms of rocks was a factor of 3. So I say, look, something is unusual about this object. Let's be open-minded. Let's look for more objects like it. And just today, there was a paper in the archive talking about chasing Oumuamua, which I think is not a good idea. We can talk more about, but I'm also saying the other meteors that we found from interstellar space, they also seemed weird in terms of material strength. So we already know that most of the matter in the universe is dark. We call it dark matter. It's a substance that is not the same that we find in the solar system. So if we know that most of the stuff in the universe is something different than the solar system, why is it so difficult to imagine that objects that enter the solar system are not the same as objects we found in the solar system? It's just like going to your backyard and you're used to finding rocks in your backyard. They are familiar. And then suddenly you see a tennis ball, and that was thrown by a neighbor. So you can insist that it's a rock of a type that we've never seen before. But I would argue, let's be open-minded and search for more.
Mm-hmm. Yeah, of course. I mean, the idea that Oumuamua is an artificial object. It's a perfectly legitimate scientific hypothesis, and I think where we divided and the scientific community has different opinion is whether we have already sufficient evidence to reach a final conclusion or not.
I'm not reaching a final conclusion. And by the way,
exactly.
I would not separate myself from the scientific community. I'm a scientist. It's not as if there is a scientific community and there is me. I am a scientist. I represent science.
Yes, absolutely. No, okay. But I know, and you already said and argued about you explained that there were many papers dealing with other explanations, and to the best of my knowledge, you replied to all of them, including the last one that was published in Nature recently. So perhaps the point here is that we do not have enough data yet to settle the issue, and we can always find explanations that fit the available evidence, and one may incline toward one explanation or the other. So,
but Amedeo, just think about the dark matter. Let me give you another example, which is part of the mainstream. We've invested $10 billion in the Large Hadron Collider, okay, at CERN. Why did we do that? The main motivation was the popular view that the dark matter is made of weakly interacting massive particles that are the lightest supersymmetric particle. Supersymmetry was a new symmetry in nature that was invoked back when I started doing astrophysics, and it was believed by the mainstream of the particle physics community to the level that $10 billion were allocated to find supersymmetry in the natural range of parameters. We put $10 billion. We did the experiment. We didn't find supersymmetry. Now, what does it teach us? First of all, it was not proven. You may argue extraordinary claims require extraordinary evidence. Well, my point is extraordinary evidence requires extraordinary funding. If you are not putting money towards the search and collecting new evidence, you will not find extraordinary evidence. So nobody expected Oumuamua. That's why the data is incomplete. We need to put money, just like we put in the search for dark matter, in order to find more evidence and have it extraordinary. That's very simple, very simple. But on this subject, the mainstream says, no. We are confident, it's natural. We don't want to put any money. There is no study of a future, I'm not talking about $10 billion. And I think, by the way, this is a more important scientific problem than the question of dark matter, which has zero impact on our daily lives. If we find that there is another intelligent technological civilization out there, it would have a huge impact on society. So how can we ignore this question and invest $10 billion in the search for dark matter? And my point is, at the same time, you might say, okay, well, maybe the mainstream is conservative. Not at all. For 30 years, string theories are working on extra dimensions, the multiverse, ideas that were not tested and will not be tested in our lifetime. And that is considered part of the mainstream. Extra dimensions? Sure, let's talk about it. Let it be part of the conversation. Let's invest money in experiments testing it. The other thing I should mention, the SETI community is hostile to the search for objects. For 70 years, they were searching for radio signals. Now you ask yourself, is that professional for them to resist the study of objects? After all, it could be technological signatures. And to me, it sounds like people who believe that the dark matter is the lightest supersymmetric particle, banning any discussion about the dark matter being an axion. That is not professional. I've never heard about particle physicists organizing conferences in which they ban the discussion of axions as the dark matter. However, the SETI community banned the discussion on objects near Earth that might be of technological origin as part of their conversation on technological signatures of extraterrestrial civilizations. So something is wrong in the current academic culture.
So what would be a way of getting further evidence on Oumuamua, in your opinion?
It's very simple. It's very simple. It's not okay. So today there was a paper in the archive suggesting a project called Lyra. The students can easily find it, where the suggestion is that within the coming century, we could send a spacecraft that will chase Oumuamua. It's sort of like going on a date, liking the person that you dated with, but the person is already out the door and you don't have their phone number. So you are obsessing with that person and you say, okay, I'll go to the street, chase this person and find it. And I think it's the wrong approach, because Oumuamua now is 10 million times fainter than it was close to Earth. It's very difficult to see it. And the trajectory is not so precisely defined. You have to look through a telescope and find exactly where it is when you're chasing it. And moreover, you have to come very close to it, which is impossible based on the numbers that I calculated this morning. And moreover, you will pass near it for a very short amount of time, a few minutes, so that you can resolve its image. It's much better to continue to search the sky for the next Oumuamua. And we have a dating app for that. It's called the Vera C. Rubin Observatory in Chile, that will have LSST, a survey of the southern sky every 4 days with a camera of 3.2 billion pixels. So, it's 1,000 times more pixels than you have on your cell phone. And it will definitely find another Oumuamua every year based on simple calculations. So what we should do is find the next Oumuamua and then get data on it. And now we have the Webb telescope 1.5 million kilometers away from Earth. So you can do a parallax, basically measure the motion of such an object that passes near the orbit of Earth around the sun, measure it in 3 dimensions very precisely, and check whether there is any propulsion of the object. Moreover, you can detect the infrared emission from any object, which is the heat associated with the warming of the surface of the object by sunlight. So that will tell us the size of the object and the albedo, the reflectance of the object, because for Oumuamua, we could only see the reflection of sunlight. So we don't know what the reflectance was. But if we detect the emission of the infrared emission from the object, we can tell what the surface area is, because the temperature of any object is just dependent on its distance from the sun. And so altogether, I think we have a much better chance at characterizing the next Oumuamua. That's what we should do. And moreover, we can go after, meteors that came from interstellar space to check if there are spacecraft or rocks. That's what I'm doing this summer. We will go to the Pacific Ocean and try to collect the fragments from the first interstellar meteor and tell from the composition whether it was a rock or some artificial alloy like stainless steel. I should say also that in 2020, September 2020, there was another object discovered by the same telescope in Hawaii that discovered Oumuamua, which exhibited a push by reflection of sunlight no cometary tail. It was given the name 2020 SO. And a few weeks later, the astronomers in Hawaii, they never wrote a paper about it because they realized it's actually a rocket booster that was launched by NASA in 1966. And it was made of stainless steel, and it had very thin walls. So here we have an example of a thin object that was definitely artificial because we produced it. The question is, who produced Oumuamua?
Okay, I just want to touch on for the final question on a more general topic. And you say that the scientific community is too conservative when it comes to the question of whether there is other life in the universe. And to some extent, this is true. There are many scientists who see the hypothesis of extraterrestrial life as too far-fetched, and they will not change their mind very easily. Perhaps they won't change their mind at all, no matter what the evidence. But there are also many scientists, including me, that are open to this investigation, especially now that the tools are getting better, and that would very much like to have a positive answer. So rather than being conservative, I think it is more of a question of being very cautious, because it is hard to get good evidence, and there are many examples of supposed discoveries in this field and also in other fields that had to be retracted after further studies. And also in general, as a society, we are flooded by misinformation and claims based on insufficient evidence, and it's natural to have a defensive attitude.
No, it's not natural at all, and let me explain.
So let me make the question, and then you can explain. So okay. My final question is, would it be better to say we don't know until we do know? So we don't know what Oumuamua is. We want to find out. It is okay not to know. We want to find out, but we suspend our judgment for the time being. And can this be a valuable message as a scientist, especially for the younger generations, that there is no problem in not knowing?
Okay, the issue is not that. You can have whatever opinion you want when the data is incomplete. That's completely fine. We can think that dark matter is an axion. We can think that dark matter is a weakly interacting massive particle. We just don't have enough data. That's the standard situation in science. The problem is not that. You can have whatever opinion. Science is not about opinion. Science is about evidence. Now, what does it mean? It means that if you regard science as the weather, you say, I will accept whatever comes my way. I will just see if the sun shines today, and then I'll go out, without an umbrella. Tomorrow there might be rain. I'll put an umbrella. That's not up to me. Whether there is rain or no rain, it's not up to me. I will adjust to whatever circumstances nature gives me. That's the wrong approach to science. Because science is all about seeking the evidence, investing money, investing time, not sitting on your sofa like Enrico Fermi did back in Los Alamos at lunch saying, where is everybody? I don't see anyone around me, therefore I don't have neighbors. That's like a single person saying, I don't see any partner next to me, therefore I will assume that there is no partner anywhere for me, I will remain single. That's a self-fulfilling prophecy. So if you say the data is not enough, and at the same time you say, let's see, if there will be data, then I might change my opinion. Then that's a self-fulfilling prophecy. That's exactly what the clergy was doing to Galileo. They said, we don't want actually to look at the data. We don't want to collect new data because we are better off continuing the same, thinking that we had for millennia. We better have that than collect new data and change our opinion. If that's your approach, you will never change your opinion. But the approach of a real scientist, especially young scientists like those that are listening, should be, let's go out and collect the data, the evidence, so that we can check the answer rather than accept what people tell us, okay? And that's a completely different thing because you have to invest money until, the scientists that are saying, I'm not convinced, until they put billions of dollars billions of dollars towards checking what interstellar objects are, their argument is a self-fulfilling prophecy. They have to put the money, they have to put their time, their research time, instead of studying whether the dark matter is an axion or a weakly interacting massive particle. I want them to dedicate a substantial fraction of the time to finding out what interstellar objects are, just like they're trying to find out what the dark matter is for 40, 50 years now. We haven't found it. We invested a huge amount of money. We put a lot of time. Look at the scientific literature is filled with papers suggesting this or that, working on it day and night. At the same time, with respect to interstellar objects, how many people are working on it? Almost nothing. People are spectators looking at it, just like Enrico Fermi. Where is everybody? I don't see anything. Of course, if you don't go to dating site, if you don't look through your windows and check whether you have neighbors, you will not find any neighbors. So what I'm saying is, let's build observatories, let's collect data that would allow us to get to the bottom of it, to find out the evidence, not assume that the evidence will come our way without doing anything, because that's a self-fulfilling prophecy. Now, what am I doing? Well, I established the Galileo project to celebrate Galileo's approach of looking through the telescope. We have an operating observatory at Harvard University collecting data on the sky 24/7 in the infrared, optical, radio, and audio, and we're analyzing it with artificial intelligence software. We have an expedition to the Pacific Ocean to look after the first interstellar meteor. I also work with my postdocs designing the software that will use data from the Vera Rubin Observatory, from the LSST, and look for interstellar objects. Just to give you an example, this is a facility, the LSST on the Rubin Observatory, facility supported by the National Science Foundation. I asked the people responsible for the software that analyzes the pipeline, the data will be public. I asked them, when you find objects in the sky, does the software allow you to look for interstellar objects? Very simple. They said, no. Why should we look for it? We are looking just for objects that are bound to the sun. These are comets or asteroids. I'm talking about this year, 2023, when LSST is supposed to give us a flood of data within a year. So here is my point. Not only that people are not investing new funds, not only they're not putting the research time, but also they're putting blinders. They put software into the LSST pipeline that will identify only objects bound to the sun. When you fit their orbit, it has to have a positive eccentricity. It's only objects bound to this. So I'm saying, imagine that I did not exist, that you deleted me. Okay, Avi Loeb, no Avi Loeb in the world, okay? Then there would be this software looking at LSST data and identifying comets, asteroids bound to the sun. And people would say, we don't see anything interstellar. And I say, well, it's because your software does not allow for that. So I'm talking 2023, state-of-the-art data from LSST being analyzed by software that is not allowing you to detect interstellar objects, after I've been talking about interstellar objects for several years. And you tell me, oh, everyone is open-minded. How do you put these two together?
Yeah, I think we can agree on this final point that we should look better, and it is an important issue, and we should do any effort to come up with some definite conclusion at some point. So I share this, and I think we can agree on this. And
well, I'm saying this is the biggest question that humanity, the biggest scientific question for humanity, and yet we are not investing even 1% of the budget allocated to science to address it, when we are addressing questions like extra dimensions, like the dark matter, which have no impact on people's lives. Mm-hmm. Something is wrong in the priority. And then at the same time saying, oh, we are open-minded, but there is no conclusive evidence. Of course, there will not be conclusive evidence if we never invest the effort to find it.
Mm-hmm. Okay. So thank you so much, Amedeo and Avi, for this interesting and passionate conversation. I think that you gave a lot of suggestions and ideas to reflect on to all our students that are written a lot actually of questions. So we have around 10 minutes left, 10 to 15. So I try to select some of them. I apologize if by any chance you hear some background noise here, but I try to go ahead. So there are 3 or 4 messages that focus on the role, Avi, of philosophy also. For example, Valeria Simone from the Liceo Classico Campanella in Reggio Calabria. She writes, in the chapter The Farm, you establish a comparison between philosophers and astrophysicists, and also one between children and adults. Do you believe that astrophysicists have to be a bit like children to be able to answer the important question posed by philosophers and religious people in the past? And also, there is Michele from the Liceo Classico in Potenza. In the book, it said that philosophers have an important role in science. What is their role specifically? So may you comment on the relationship between philosophy and science on this issue?
Yeah, these are extremely important questions because they trace back to my childhood. And I haven't changed much from growing up on a farm. There was I remember one experience that frustrated me a lot as a kid. I would sit at the dinner table and ask a difficult question. And the adults in the room would either dismiss the question or invent a story that made no sense to me as a child. And it was obvious to me that they don't know what they're talking about. And I thought that by becoming a scientist, I could answer the question myself. But what I see is, again, people pretending to be the adults in the room when they don't know the answer. And they pretend to know the answer without knowing the evidence that will support it. And instead of seeking the evidence, it's much easier to have an opinion than to follow the evidence, because it requires hard work to collect evidence beyond a reasonable doubt. So you can always say, oh, the evidence is not good enough, I have this and that opinion. That's what happens in politics, that's what happens in religion, but it should not be the case in science. If there is a question that is intriguing, exciting, let's say, oh, that's very exciting, let's find out the answer. Let's put $10 billion to it. And that's what we are doing in the dark matter search. But why is it so difficult to do it in the search for extraterrestrials? Because we prefer to believe that we are the smartest beings that ever existed since the Big Bang. So that Albert Einstein was the smartest scientist who existed since the Big Bang. I disagree with that. I think since there are hundreds of billions of stars in the Milky Way galaxy alone, it's very likely there was a scientist smarter than Albert Einstein. And moreover, I would argue that most of these civilizations died by now because most stars formed billions of years before the sun, and we should just look for them. And out of modesty, it's arrogant to think that we are the center of the universe, that we are the smartest that ever lived. So with respect to philosophy, as a young kid, I was mostly excited about philosophy because of the big picture, because of the fundamental questions that it addresses. And I ended up as an astrophysicist by circumstances. But I realized that it's a blessing because it's sort of like an arranged marriage that circumstances of life led me to. But I'm actually married to my true love, especially with respect to questions like, is there someone else out there like us? Because I think it will give us a meaning. You know, Steven Weinberg, in his book, The Last 3 Minutes, towards the end of the book, he said, the more the universe appears to be comprehensible to us, the more pointless it looks. And if you look at cosmological simulations nowadays, you know, what is our purpose? It's completely pointless. There are so many galaxies, so many stars out there. You know, our life is pointless. Now, my point of view is, no, you are wrong. If there is a partner, we know from private life that when we find a partner, it gives a meaning to our life. So if we find an intelligent species out there, it will give a meaning to our cosmic existence. We could learn from them. We could be better, not just fight with each other, try to kill each other. These are the adults in the room. The adults in the room right now are those that are threatening to use nuclear weapons in Ukraine. The adults in the room are the people who initiated the Second World War. Is that really the image we want to have? It's much better to be a kid, curious about the universe, than to kill each other. So I would argue the adults in the room are childish. The kids are the mature ones.
Okay, thank you for this answer. That in part answers also to a question put by Souza, who asks, will our attitudes as human beings be peaceful? Will we be looking for conflicts and wars to prevail, or will we try to coexist and collaborate? But I want to mention a couple of other questions that are specifically about the writing of your book. Letizia asks which chapter of the book was the most difficult to write, especially from a communication point of view. And another specific question is, let me find it. It's about what is the origin of the name Filters? What inspires the title of the chapter in your book?
Yeah, so I think the most difficult part for me was my own personal history that I described in the book. I should also mention that there is a new book coming out in 4 months. It's called The Interstellar. I just received a hard copy, the first one, the galley proofs of the book. And it will also be hopefully translated to Italian, so you could see it. It will be coming soon in a few months, and it talks about the implications to humanity. With respect to the chapter headings, many of them were inspired by my regular essays in medium.com. So if you just put my name, Avi Loeb, Medium, medium.com, you will find that every couple of days, every few days, I post an essay there, and I discuss things that were used for the first book, are used for the second book, and many of these titles were inspired by the essays.
Okay. In the meantime, I posted on the chat the website medium.com and the page of written and the articles written by Avi Loeb, so you can find it and click straight. And
you can subscribe for free, because I'm not getting paid for that. So you can just subscribe if you are interested.
Okay. There are a bunch of comments and questions about the role of prejudice in science. So I would like to mention this one just to let you comment again on this. Elisa writes, do you believe there is actually a material limit to man's ability to understand, or that, as happened to Zwicky, we have the skills to know, but we are blocked by the prejudice against new hypotheses?
Yeah, so trying to understand the prejudice has to do with psychology. And the way I see it is that experts, you can look at senior people that you are familiar with as students, and the senior people very often care about their reputation, their stature, so that they can get more honors and awards. And what they are working on is building an echo chamber of students and postdocs that repeat their mantras. Basically, if they were responsible for finding how black holes form at the centers of galaxies, they want their students and postdocs to work on how black holes form at the centers of galaxies and reference the work that they did for many years about the subject, so that their voice will be louder. They just want the students and postdocs to be amplifiers of their image in the scientific community. Now imagine a situation where the past knowledge is missing something really crucial. What these experts advocated for decades is incomplete. Like, for example, an expert working on rocks in the solar system just missed the possibility that objects from outside the solar system are not rocks. Just think about it. That will be threatening to these people, because it would imply, first of all, they were not responsible for this new knowledge, which is like completely surprising. Second, it's much more exciting to talk about something that they don't know. And so people will forget about their stature, their prestige. So they resist a change and they want to celebrate past knowledge. They don't want to celebrate new knowledge unless they discover the new knowledge. And, that's why there is resistance. That's why there is prejudice. People want to protect their own self-image. And as a result of that, they discourage young people from pursuing innovative ideas. And that's very bad for science, because if you think about it, young people have no baggage. They have nothing to preserve from the past. And you would expect them to be the innovators, just like Albert Einstein came up with completely different ideas. So when the senior people say, you will not get a job unless you work on the ideas that are popular right now, this is very bad for the progress of science, because who will explore new knowledge in that case? And, I once attended a PhD defense at Harvard University, the physics department. And the student was supposed to do, research, a new method to use the clustering of galaxies to test the cold dark matter paradigm. So I asked a simple question. I said, suppose new data will disagree, according to your model, with the cold dark matter paradigm. What would it mean? Does it mean that the cold dark matter paradigm is wrong? The student said, no. It would mean that the model that I worked on needs more parameters. And then I thought to myself, what's the purpose of this PhD thesis? If the answer is known in advance that cold dark matter must be right, why at all devise a test for that? And the same was true by a senior person that works on string theory, one of the most prominent string theories. He gave a colloquium and he said, here is a new idea, the swampland in the string landscape. And I said, okay, you are predicting something about the microwave background anisotropies. Suppose we measure them and we show that it's incorrect. Will it rule out string theory? And he said, no, string theory will always be correct. It would mean that my conjecture is wrong. So you see, if you work with this approach, then there will never be progress in our knowledge, because you're not allowing ideas to be falsified. And that's a fundamental part of doing science. So that's the way I see prejudice. It's people wanting to preserve their territory. And the best way to preserve your intellectual territory is not to have experiments at all. That's what string theories are doing. It's very comfortable. You will never be proven wrong. You can do intellectual gymnastics, never do an experiment, and you can celebrate your intelligence, how wonderful you are. And that's in the context of not having experiments at all. But another variant of that is what I spoke with Amedeo before, and that is to say, I'm not convinced by the current evidence. And by the way, I'm not planning to seek any new evidence so that I will feel comfortable intellectually and I will never be proven wrong. That's another variant of the same intellectual problem that I see.
Okay, thank you again, Avi, for this passionate answer, which will surely inspire our students who will be reading with much more interest, I guess now, your book, Non siamo soli. I remember that the Italian translation was made by Tullio Canillo. The book is published by Mondadori. We can't wait to read also the translation of your new book, Interstellar. We are pretty curious about that. So I think we have to stop here. And I want to thank you so much for being with us.
Thank you so much. I should say that couple of weeks ago, I received an email, and the title of the email was Avi Loeb on Broadway. And that was that was just around the April Fool's Day, so I thought it's a joke. But then the sender of the email showed attached some photographs with Dick Van Dyke from Mary Poppins, and said that he produced a play about Dick Van Dyke, and he wants to do a play about, you know, my work, the thing that we discussed. And he already wrote the play by now. And I should say that is, you know, it's very rewarding to see people out in the public that appreciate this approach. And however, within academia, it's not easy to find people that are welcoming innovation, welcoming new ideas, saying that makes my life interesting. You know, that's exciting. Let's go and search for it. Why is that so difficult? I just don't understand that. But I hope that more will join, and eventually we'll figure out what, you know, what interstellar objects are all about, and whether any of them is of technological origin.
So we'll pretty soon see some new show on Broadway, right?
Well, yeah, hopefully within a year or so. I mean, he already wrote it. Okay. He's waiting for the final, the conclusion part. He's waiting to see what the outcome of the expedition will be.
Okay.
So we shall see what we find.
Okay. So thank you again, Avi Loeb, for being with us this afternoon.
Thank you for having me. It's a great pleasure. Thank you, Amedeo. I really enjoyed your questions.
Thank you, Avi.
I want to really thank Amedeo Balbi for being with us and discuss with Avi about his book, and giving us, all of us, a perspective on this issue. So thank you to all the students, of course, that have participated with their questions and comments. This was the fourth meeting of this year's presentation for the Cosmos Prize. The last one will be on next Wednesday with Jim Al-Khalili about his new book Le Gioie della Scienza. He will be talking with another of the scientists of the scientific committee of the Cosmos Prize. So thank you again, and have a good afternoon and evening to everybody. Ciao.